by what type. So the blue is direct emissions, which is carbon emissions that it's going to make every time that it's, you know, producing electricity basically. And then indirect emissions is the emissions it costs to build the plant in the first place. All the renewables have a little bit of this green because it does cost a little bit to do the construction, to build the dam that holds back all the water for hydro, to build solar panels, does take some carbon emissions. And then the blue, the little tiny little bits of blue are backup electricity, so diesel generators, things like that. And nuclear and wind are the two lowest here. So this is why we do want to slowly build more of this, and as these grow old, to replace them with these, you know, and slowly make that transition. So that's kind of what's going on the energy side. On the transportation side, it's pretty simple. It's really just this oil part here, and there's a lot of different research going on to try to see if we can replace this with hydrogen fuel cells to increase the usage of electric cars, to make sure that there's more access to public transportation, right? Because a big part of our emissions from the transportation sector, which is like a third of our total energy, that comes from people not having access to public transportation, like public trains, public buses, and people having to drive their cars everywhere. Another big part comes from shipping and the trucking industry, and that's its own can of worms that there are people in business working to solve, but it's definitely not coming as far along as, let's say, electric cars, because, you know, you see a lot of electric cars on the road, but no one ever sees electric trucks on the road. That's not a thing yet, unfortunately. The third big one that I don't have a slide on, but that's okay, is agriculture. And that's because methane, if you remember, there are two big gases, were carbon dioxide and methane. And methane is about 30 times worse in terms of its ability to trap heat than carbon dioxide. So even though we're making way more carbon dioxide, we are still slowly making a little bit more methane from the beef and dairy industry specifically. And so as we make more methane, each, you know, increment in more methane that we produce represents about 30 times the increments of carbon dioxide that we produce. So that's why, you know, agriculture is something that climate scientists and environmentalists look at too. So that's kind of like our basic, like that's why there is climate change. That kind of is my little short explanation on, you know, what's causing it, how are humans contributing. So I only intended to take like 30 minutes so that way I could get to any and all questions, and I hope that there are some, or just other topics of discussion that are somewhat relevant.
Uh, since you said there weren't many like electric trucks on the road or any at all, do you think it will make a big impact on like the climate if a lot of companies started using electric trucks instead of gas-powered trucks?
I do think so, but unfortunately the shipping and trucking industries are a really, really far, like super far away from going more electric. I think I'm allowed to say this, but I do know that the Department of Defense and the US military is working on trying to see if they can get like a nuclear power plant to fit on a truck, so that way it can provide more mobile electricity. And so like as nuclear power plants like slowly get smaller and smaller and smaller, hopefully the idea is that one day we'll have like a little tiny reactor that can fit on a truck and then power an electric truck. But I don't know, I don't believe that like currently like electric trucks that have to like charge overnight and then drive, that like don't have some kind of source of electricity like in the truck, is something that's really seriously being looked at the moment, unfortunately.
Thanks, Steph.
Yeah.
That's
Oh, but shipping
like,
is definitely being worked on because they do want to put little reactors on ships for sure. So that's probably going to come first. Hi, Ava. Sorry, Adrian, did you have a question?
Yeah, I just want to go all the way back to where we started, at climate, right?
Mhm.
Because I know everybody hears about climate change, climate this, climate that, but explain to us what exactly is climate?
Like, what is climate?
Uh-huh.
So, um, you know how, I guess, are you kind of more asking like the difference between weather and climate?
Yeah, because I think people uh, distinguish that the earth is heating up or it's cooling off. It's like the average temperature changes over a period of time because of these elements that you were mentioning in your presentation. So probably just expand on the climate and what what is the changes that are occurring to the earth, and maybe climate change isn't even part of what's happening on the planet, but outer space too, that affects our the changes on Earth.
Yeah, so you know how, like, depending on where you live, I know a lot of you guys are on the West Coast, how you kind of go through the seasons and you have winter in the December, January, February months, and then it goes through spring, summer, fall, and then back to winter. But and that's kind of like your what your weather patterns look like. That's kind of what your climate looks like. That's considered like a temperate climate where it kind of fluctuates between hot and cold depending on like where the earth is. Um, and in different parts of the earth, obviously they have different types of climates, right? Like in the video, she talked about the desert. There's obviously the Arctic. And so that's kind of like what your climate looks like. Climate change is when like your overall climate, not the day-to-day weather, but kind of like how hot your average summer day is, or how cold your average winter is, or how much rain or how much snowfall you get. If those like averages change over time, and we're talking over like a long period of time, so over the course of like, let's say 10 years, did our summers get significantly hotter over the course of 10 years? And the answer to that is factually yes. On average, the Earth has been heating up slowly over the course of the last about 100 years, but that change in temperature is a lot greater than the change in temperature that we should have expected over the last 100 years when you compare to like historical data. And they know what the temperature of the Earth was for the past couple thousand years because of there are certain radionuclides and ways that scientists can use certain like very fancy radiation related dating procedures to figure out temperatures in the earth. And this is a lot due to ice cores in like current like large glaciers. But there's very fancy science that I am not an expert in as to how they get the temperature of the earth from past several thousand years. But they were able to figure it out over a long period of time and figure out that recently our changes have been bigger than past changes over time. So that's how we know that the Industrial Revolution in the 1800s and the continuation of technology that was created during the Industrial Revolution being commercialized and then mass produced, and then everybody driving a car, and then everyone's house getting electricity, and then every country developing their electricity markets, and then everyone gets a coal power plant, everyone's starting to get natural gas plants now. So like that rapid expansion is what we're attributing our effect on climate change to be from. So Isabel asks, are the effects of climate change reversible? And to some extent, but not fully. So the way that we would do this, remember how I said that some gases actually do reflect heat? One of those is sulfur dioxide, which is SO2. This isn't necessarily a gas. This is kind of like a solid powder situation. We would basically be injecting what's gonna become sulfuric acid into the atmosphere. And that would be kind of like, let's say over here, we put in a puff of sulfur dioxide, and usually we do this over the ocean, so that way when it rains, we don't rain acid on Earth. So we would do this over the ocean, so that way, at least over this cloud, the heat from the sun that hits this little cloud of sulfur is going to be reflected. And so that's one way that we can kind of like slow it down. Or let's say we start actually ramping up our renewables production and ramping down our fossil fuels production, then we can also combine those efforts with things like this to kind of try to reflect heat. Another big one is what's called carbon sequestration, and I can type that word in the chat. It's also known as carbon capture. So that means that we're taking carbon dioxide and trying to figure out how to store it somehow. So we're just taking some of the carbon dioxide in the air and just taking it out of the air. So that way there's just less carbon dioxide and less things trapping heat. One way to do this is to grow a whole forest of trees, let the trees eat all the carbon dioxide, turn it into oxygen, and then you cut down all the trees and then you bury them in the ground. So now you've trapped your carbon in the trees, and that works. Another way to do it is to get big blankets of algae that you would create in the ocean and kind of let them grow with one another. Algae is another organism that will eat a bunch of carbon dioxide, produce a bunch of oxygen, and then when they die, they sink to the bottom of the ocean. That's another very simple, easy way to store carbon. So efforts like just taking carbon dioxide out the air and trying to reflect heat with sulfur, those are two big ways that we can try to kind of mitigate the current climate situation that we already have, but those things aren't enough to account for the current changes that are still being made to the climate. So we would have to do those in conjunction with making changes like switching to renewables, more public transportation, electric cars or hydrogen fuel cell cars, and changes in the agricultural industry as well. So those are, there's like several different solutions, but the ideal is to do all of them at the same time. Are there other questions? I'm also happy to talk about, because I know some of you are in middle school, and then I think, Marcus, how old are you?
I'm a junior, I'm 16.
Yeah, I thought you were older. Okay. Yeah, so if like anyone has questions about like college or whatever, I just finished that.
Yeah, I take computer science. I'm on my second course.
Yeah, I do remember you from the programming one too. You were the one that was like, yeah, I already know this. Like,
yeah, I do remember that one. I remember that one.
Leanne says, since nuclear produces hazardous waste as a sustainable energy option, are we running out of space to store the waste? Oh, Isabel's also in high school. Nice. I think last time you were maybe in 8th grade or entering high school. I don't remember the last time we did this though. I don't remember what month it was. Okay, so that's a good question. So I think there's kind of two parts to that question, which is how much nuclear waste is there and what are we going to do with it? And is that viable? So I kind of want to answer the second half first to make it easier to answer the overall question. So first of all, this is kind of like a fun fact. If all the power you ever used came from nuclear, the waste that nuclear power would produce for all the energy you use in your whole life could fit into like a Coke can. The thing with nuclear is that, oh, I'm gonna go back to the whiteboard. Bring me to the whiteboard. How do I make a new page? I want a new page. I don't know how to, there's a way. Oh, haha, okay. So in chemistry, I guess I'm gonna take a couple steps back. I'm gonna take several steps back actually. So we're gonna go back to fossil fuels and then compare to nuclear. So let's say I wanna burn natural gas and make electricity. So the way that I would do this, I know that not all of you have seen chemistry before, is you have to add oxygen right? Like, you know how like if you have a fire and you take away all the oxygen, the fire goes out? It's the same thing. It kind of needs that as fuel. And so if this is my natural gas, this is my methane. I'm adding oxygen, and you would make CO2 and water. And if I really want to balance this, I think I have to have 2 of these, 1, 2, 3, 4, 1, 2, 3, 4, and 2 of these. All right. So this is kind of what my chemical equation looks like. And kind of on a picture scale, I'm taking my methane and I'm taking my O2. And what these really are is electrons. So hydrogen is like a proton and an electron, and carbon is like 6 protons and 6 neutrons. I'm not going to draw all of them, but you get the point. In a big nucleus, and then it's got 6 electrons around it. And so these bonds are really like electrons that kind of hang out together. So that's kind of what's going on with these. And so my elements are staying the same. I'm just kind of breaking apart their bonds. I'm separating the electrons. So that way they can rearrange themselves into CO2 and H2O. I have 2 O2s and I have 2 H2Os. So I'm kind of just taking all of my elements, breaking them apart, and then rearranging them, right? And if you count, I have the same number of all the elements. Whereas does this kind of make sense, first of all, before I move on? Okay, I can't see your faces. I can only hear because I'm sharing screen. A nuclear reaction, however, is, let's say I have uranium, which is the element that we use in nuclear reactions. And this guy has, I'm just going to call him U. He has 92 protons and 92 electrons and some number of neutrons that I would have to get a calculator to find out. But it's whatever 235 minus 92 is. Whatever that is, that's the number of neutrons. So I have all my protons and neutrons in the middle, and I have 92 electrons floating in all these rings on the outside, where this is kind of my middle. And then I have all these protons and electrons. Now I'm not doing any kind of chemical reaction. There's only one element here, and that's uranium. But what I'm doing is I'm splitting up the middle part. I'm like, what if I just kind of cut the whole thing? And I said, all right, this part is going to become, I don't know, barium. And I make something smaller. And I'd probably have to Google and figure out what the other half would be, or I'd have to do some quick math. But then maybe I'm going to make something else, like krypton. I think that's actually right. And like you don't necessarily split uranium in half 50-50. It can split into a bunch of different things, like maybe you do a 60-40 split or like a 20-80 split. And so you can make a lot of different smaller elements with this, but I'm basically taking an atom and I'm breaking it apart and splitting it into 2 other things. And what nuclear waste is that sometimes these things might, when it breaks apart, it might be radioactive. Right? Sometimes it breaks into something that's just like completely unstable. Oh, there's things in the chat. What's going on in the chat? Okay, we'll get to that one too. So these things can sometimes be radioactive, and that's what our nuclear waste is. Sometimes they're not. Sometimes they're just stable. But all of those things are generally included in the nuclear waste too, because reprocessing and kind of splitting up what is bad and what's good is currently not allowed in the United States, so we can't reprocess and just separate off the bad parts. So we just consider the whole thing high-level waste. We take all the fuel and we're just saying, this fuel's been used, there's waste somewhere in it, we're not going to separate it, and that whole thing is considered waste. So that's what it is, first of all. Now, kind of comparing between chemistry and nuclear, which one do you think is going to make more energy? Which type of reaction makes more energy out? You can also type in the chat if you want. There are no answers yet. Okay, someone said nuclear so far. We have 1 vote for nuclear. I guess the question here is, what's going to make more energy? Breaking bonds between electrons, breaking electric bonds or chemical bonds, or breaking bonds inside the nucleus, or nuclear bonds? Also for reference, this is okay. We have 1 vote for chemical and 3 votes for nuclear. I don't know, maybe I can, ooh, here's an idea. Do I know how to make a poll? Making a poll would take too long. This is fine. We had 3 votes for nuclear and 1 vote for chemical. The answer is nuclear. Basically, so what's going on is when you take an atom, which I guess I have a picture of on my shirt, and you split the nucleus, you make a lot more energy than when you just kind of rearrange the electrons. The electrons are already pretty mobile, so they're pretty easy to rearrange and like move the elements wherever you want. But breaking an element takes a whole lot more energy, and when you do that, you actually get a lot more energy out. Right, and so one of those reasons is because uranium-235 isn't the most stable atom in the world, and so it's pretty happy to be broken apart into things that are a little bit more stable. So because you make more energy from a nuclear reaction, you actually need less fuel, right? To get the same amount of, if I want 1,000 megawatts of electricity, I would need like a whole train car, probably multiple train cars of coal, versus like a little Tootsie Roll sized of uranium. So if you need less fuel, then you also make less waste, right? Does that like make sense? So that kind of explains the soda can thing, right? Another one is a whole nuclear power plant operating for a whole year only makes the amount of waste that could fit under the chair that you're sitting in. Oh, Ava has to go. Oh, I did want to get to Ava's question, which is there a way around spending lots of money on renewable energy? There's not. The answer is no. That's the short answer. All right, well, she left. Okay. So this is what we store it in. Nuclear waste gets stored in these things called dry casks, which are these like giant cement cylinders that kind of sit in parking lots. And this is at every nuclear power plant in the whole United States. They all store their own waste on site. They have their own security that watches it. And it just kind of sits there. If we were to put all of them on a football field in the whole United States, it would only stack to like 24 feet tall. So when there's a question of like, are we running out of room to store it? No, because these plants have a lot of space just kind of around them, and they store their own nuclear waste there. There are some spaces for interim or temporary storage in the United States. They're usually in like really dry locations like New Mexico. And a lot of those, or the other one is Hanford in Washington, are also used for medical waste, a lot of the time low-level waste from power plants, and like military waste. But like high-level spent nuclear fuel from like a power plant, like those fission products, those are not stored. Those are not transported across the country, and they're not stored at temp storage facilities. They're just kept at the plant that they were made, and there's nothing that anyone can do with them because the government doesn't have a place to put them yet, but that's on the government. Thing I've been doing, and I actually got to talk to Dr. Rita Barenwall about 3 hours ago, who is like anyone, like she is the top dog in nuclear, period. She runs the Office of Nuclear Science in the Department of Energy in the Trump administration, and she is, I was starstruck the whole time. But I actually asked her about, when does she think the US government is going to give us long-term geologic repositories to store our nuclear waste, or our high-level nuclear waste. And she said she has absolutely no idea, but it's going to take forever. So the reason is because it took, Yucca Mountain was several years in the making, out in Nevada, and Nevada said, we don't want Yucca Mountain to be finished, so the US government isn't going to finish Yucca Mountain, and to spend that amount of time on starting from scratch in a new project, she thinks will take a very, very long time. So I trust her judgment on that. So we currently have nowhere to put it, other than keeping it at the plants that they were made, which is so far not a problem, but that doesn't mean that we should be irresponsible and do nothing with it. Can the waste also be used for energy? That's a great question, because the answer is yes. So there are these super fancy nuclear reactors called fast breeder reactors, and they basically use a different type of nuclear reaction that will use the most, basically the worst parts of the nuclear waste as fuel. So they can either use uranium-238, which is just a part of the uranium that we just don't use, or some of the longer-lived isotopes that are in there, the things that would make the nuclear waste last, you know, more than 1,000 years. They can take those parts of the waste and turn them into fuel. And so those types of fancy reactors are currently still looking for funding from the US government and funding from private industry so they can develop and become, like, you know, potentially something that we could use for commercial energy in the future. So a lot of people like to say that we're closing the fuel cycle, because then we're turning our waste back into fuel. So then all of the waste that we really can't use for fuel is still technically radioactive and still would need to be stored. What would be left over would be waste that only kind of lives for maximum 1,000 years instead of like tens of thousands of years. So we wouldn't have to take care of it for as long if we were able to reprocess the longest lived isotopes. Okay, I think I've addressed everything in chat so far. And we are 13 minutes away from 8:30. So does anyone have, I guess, further questions? We can talk about, I don't know, college?
Yeah, talk about because I know if the people that were here last time, Alyssa, she did a completely different class on coding. This lady is like the jack of all trades here. I'm really so impressed with you. So are any of you guys, okay, you can ask Aunt Isabel's question. She has one.
She asks, what is your favorite part of your work? And I think I'm one of those people that like kind of likes to talk. I feel like when I was like in high school and like in college and growing up, that like whenever the teacher like asked a question in class, I was like that kid that would like just answer everything. So probably my favorite part is being able to share the things that I've learned with other people. So whether that be groups like you guys, I also do teach college classes, and also with people in government as well. I have spent this entire week lobbying Congress, and I actually have more meetings with House representatives on Monday. And so honestly, like getting to promote those things is something I really enjoy. So my two like career paths that I'm considering are working in public policy and potentially being a professor. So we'll see, but I guess it's kind of like a lame answer though, because I didn't really talk anything about what the work is, but that's okay.
So I know you touched on it a bit, but can you share as far as when the climate changes, what is actually happening on the planet for it to be too cold or too warm, and as far as natural disasters and stuff like that?
So in the video, it talked a lot about how how that affects plants and animals and the ecosystem. And the reason I showed the video was because I think it would do a better job than I would on talking about how it affects like the ecosystem. However, those ecosystems are also people's livelihoods, right? So in Canada, for example, climate change for them is a great thing. It increased their growing season. It's warmer for a longer period of time, so they can make some more money from their crops now. However, in countries closer to the ecosystem, it is now too hot for people to, you know, profit from agriculture. So now, like, people are like, well, what am I supposed to do? You know, so there are currently climate refugees from countries that are closest to the equator because it is simply too hot for people to realistically live there anymore. And then of course you have, so I guess there's the two extremes of where it's really hot now and then where it used to be really cold. So in the Arctic, I mean, you see pictures all the time of melting glaciers. The size of the land up there has decreased significantly because everything is melting. There's less food available for the animals that live up there. And so a lot of the things that you saw in the video are happening in a lot of different parts of the world, not just in deserts, but also where it's really cold too. Luckily, like things in, for us at least, like places in temperate areas don't notice as much of like drastic changes because we already don't have drastic weather. So that's why a lot of people like are like, oh, like this isn't affecting me. Well, just because it's not affecting you doesn't mean it's not real, right? So, but the other thing that does affect a lot of people are the increase in the number of natural disasters. So natural disasters normally happen when there are big rapid changes that are like immediate. So you have maybe like a tornado that comes from, you have like a cold front and a warm front that like hit each other, and then you have air that circulates around each other and you can get a tornado. This happens over the ocean. You get a hurricane. And so when the Earth's temperature is changing more rapidly, you're going to get more and more of those rapid changes that occur closer together in time. So to us, it feels like we're getting more natural disasters than we normally would. But that's just because they're happening closer together because the climate is changing faster. Does that like make sense? So we would see an increase in forest fires, in bigger hurricanes, tornadoes, but hurricanes, tropical storms, and forest fires are some of the biggest effects that at least the United States has seen. Deforestation of rainforests affecting climate change. I don't know to what, so the question is, how much is the deforestation of rainforests affecting climate change? I just want to slow myself down. I don't know explicitly like to what extent that's affecting climate change because, well, one, in a sense, that's kind of carbon capture, but you're not replacing the trees with anything, so you're not continuing to turn that carbon dioxide into oxygen. So there definitely is an effect, but whether or not that effect is significant is not something that I think is well known. I don't think that it's as significant as the like ramp up of carbon production. So for instance, I don't think it's as significant as, you know, how many fossil fuels we're using for electricity or for transportation or driving your car. I think those things are going to have a more significant impact, but that doesn't mean that like reduction of smaller impacts elsewhere is a bad thing either. You know, it's kind of the whole like all of the above mentality of solutions. You know, to do whatever it is that we can. We don't want to put all our eggs in one basket and just say, all right, I'm going to go all in on solar. We don't need wind. We don't need nuclear. Like, I don't think that's reasonable. I think it's the best solution is all of the solutions. But that's a good point. Yeah, deforestation is something to consider too. Oh, this is a follow-up to our last time, which is the question is there something that I would recommend about learning on Code Academy? For that, I mean, well, it kind of depends on what your interests are, what you've already kind of been doing and like what you want to do with coding, right? So if you're, I know that a lot of high schools have engineering classes that kind of teach you to do, or robotics clubs that teach you to do different things with coding or with computer software. So if you end up taking those classes, then you kind of, one, already have like a leg up in having like extra skills. And two, like it depends on what it is you want to be able to do. So when I was a freshman in college, because I didn't know how to code when I was in high school, so the earliest I can start is college. I learned, I got like a little Arduino and breadboard, and I learned how to program in C++, and like we made like a little system where we had all these like speakers and sensors, and you had to like, we would put them behind a door, and you had to knock in a certain pattern to get the door to unlock. And so like just using that as like a little example, I eventually then applied that skill to like an actual lab later on, where I had to program a little Arduino and a breadboard that told part of an experiment to move the sample back and forth because people couldn't touch it because it was inside a vacuum chamber. So like, it kind of depends on what skills you kind of think you might be interested in learning, or what you want to do with it. So I think if your high school has a class like that, or if you have a FIRST robotics team, I would recommend joining those, because then you can learn a lot of stuff that I kind of wish that I learned when I was in high school. I didn't do FIRST robotics, I didn't take engineering classes, and I feel like they probably would have better prepared me to be an engineer in college. So plus they can give you kind of more guidance on, you know, skills that they think would be good.
Well, I think you'd be an excellent professor.
So, all right, individual carbon footprint. Now, these companies, these industries out here are trying to tell everybody that it's our fault that climate change is happening. Okay, it's not. Like, if I, as a person, like, never drove my car, only took public transportation, never ate meat, or like never turned on a light, or like didn't heat my house, you're not going to see a significant change, right? Like, I think that if everybody kind of reduced their usage by like a little bit, then you would see maybe a bigger change, right? So like, you know, not keeping your house like super hot in the winter, or not keeping or blasting the AC in the summer. And I think like, you know, like long-term habits like that, if they were widely practiced by a lot of people, and there was maybe, you know, less demand for certain things, a lot of companies like that make washing machines and refrigerators and ACs and heaters are trying to make them more efficient, so that way everyone is using a little bit less energy. Those kinds of things do make a little bit of an impact, but the biggest impacts are gonna come from like large industry or systemic changes. So from you know, multiple coal plants being replaced by a nuclear plant, or you know, if we had like a more national public train system, so that way people weren't constantly driving cross country. If we had electric buses, so that way people didn't have to drive everywhere all the time. There are a lot of countries that have shown that their overall carbon footprint has been significantly decreased, not by individual choices, but by decrease in their number of coal plants, in increase in public transportation. So like those two things, honestly, if we did those two big things, we'd probably be good to go. But I don't like it when industries try to guilt consumers for making the choices that we do. Let's see. Okay, up to date on chat. There's only a minute left, so I'm gonna thank everybody for coming and listening to me ramble for like an hour.
Oh, we love you. We love watching you all the time. That's why we keep inviting Alyssa. She's just phenomenal at what she does, and I'm just so proud of her as a young woman in the industry that you're in. Just keep it up, because when we first started this, it was going to be a girls club, but our guys are just as interested, and then we want them to actually be advocates for girls when they go on to the jobs that they're in too. So by us sharing presentations together and cooperating with one another, that'll take them into college, take them into their jobs, and they can help lift women in these industries, because we don't make up a big percentage, and that's what we're trying to change. So we're going to start again. We have a lot of classes up till February. We're going to take February off and come back again in March, and then that's when we're going to invite you again. So just have a topic in mind, or you could do this one again. I could talk about this all day. You can even come to our next week. We're going to talk to relativity space, and they're going to talk about how they created the first 3D printed rocket and flew it with raw materials into outer space in 60 days it took them. And that just amazes me at the technology nowadays. So you're invited to any other of our other classes if you like, and we hope to see you again. We thank you, all the new people that came on board today. We appreciate you. Tell your friends. We're always going to have these classes, and they're always going to be free. Knowledge is free for me. We don't want to have anybody pay for a class. So thank you, Leanne, for coming, Sophia, and the rest of you guys. We'll see you next week, okay?
Thank you so much.
Thank you,
Alyssa. Fabulous, fabulous.
Adrian, if you send me the link, I'm available for those.
Yes, and you guys, if you guys need to talk to her or ask her a question after class, just email me and I'll send you her email, and there it is.
She put it in the chat.
She put it there in the chat. Yeah. Yes, perfect. Awesome. Thanks, Alyssa, and we'll be seeing you in the spring, okay?
Okay, yeah.
All right, you take care, be safe.
You too.
Bye, thank you.
Bye.